Yeah, I think if I kind of frame a little bit your question, most people, when we talk about stem cells in today's world, it's a treatment. You go somewhere,
Yes.
you get stem cells. So the question is, what kind of stem cells, what kind of injection? And what really is not talked about is that many of these stem cell treatments, well, the stem cells come from your bone marrow, your fat tissue, your blood. So that means they're in your body. They're not better because we take them out and put them back in. So for me, what I thought fascinating since day one in this whole field of stem cell research, which is if stem cells have such regenerative potential and they're already in our body, what is their role? What do they do? So in that context, a stem cell is a cell that has the ability to multiply endlessly and to transform into cells of other tissues. The best way to understand what they are is to define first what is not a stem cell. A stem cell, like a somatic cell, a cell of your heart. It will only beat, contract in its entire life. That will never do anything else, and it will never transform into anything else. So all the cells of our bodies are specialized. They do one thing, they will never transform. At the other end of the spectrum, you have stem cells. They are nothing. By nothing, I mean a stem cell does not have a function in the body other than its ability to transform into another cell that will become a somatic cells. So they are the mother cells of the body, the building blocks of the body. They are indeed the repair system of the body.
And every organ has stem cells. Like how does that work? Because I have actually a couple of questions here. Maybe I'll start with how we've been taught stem cells. You take them out, you put them back in, or there's placenta stem cells that are taken from placenta. It gets very complicated. But the whole point is we know stem cells have regenerative capabilities.
Correct.
But it gets confusing because, like, as we get older, don't our stem cells just decline? Like,
stem cells declined both in quality and in number.
okay.
So this is just a reality that we have to face. The number of stem cells declines because the red marrow converts into yellow marrow very early in our lives. By age 30, we've lost about 90% of our red marrow. And that's why we discover in our 30s that, we're no longer Superman, Wonder Woman. It's that our ability to repair is declining significantly. So yes, there's a definite decline as we age, and it is probably the most fundamental core reason why we age and we lose our health as we age. The little caveat to this that I would add is that there is this understanding right now out there floating around. I've seen it in many interviews on YouTube and with people kind of echoing this statement that past 40 years old, your stem cells are worthless. And I think it's really an exaggeration that comes from a reality, meaning your stem cells are at 40 are not as good as when you were 2.
Right.
And at 60, they're not as good as when you were 40. But we have studies done, ongoing studies, where we see significant improvement, actually normalization of cardiac function in people with congestive heart failure simply by stimulating the release of people's own stem cells by taking plant extracts. So I'm talking here 70 years old and above with chronic stable congestive heart failure. They release their own 70-year-old stem cells, and within 6 months, they have normal cardiac function. Just to say that, yes, stem cells are not as good as when you were 2, but to say that they are worthless would be almost like saying, at 50, are you as strong as when you were 15? No. Are you worthless? No.
No, I'm not.
No, you're not.
No, I'm not.
So your stem cells are good during your entire life. Not as good as when you were young, but they're good, and they do the job of repair. And that's why you age. You don't have as many, and they're not as good.
Okay, and if you're stimulating your own stem cells, wouldn't they be considered new? I don't know. Like, I'm kind of confused by that statement because I don't, as we get older, okay, the quality may not be the same, but if we're stimulating new stem cells, aren't they
Correct.
new?
They are new. They are new.
Right.
It's just the assumption in our understanding that when one cell divides into two, that these two are identical to the first one. They are. In theory, they totally are. Now,
Oh.
take that division over the entire life of an individual. Now, these stem cells have telomerase in the bone marrow. So there's no attrition of the telomere. So they are immortal. They will multiply during the entire life of an individual. But there's over time an exhaustion, let's say, could be done because of a reduction maybe of mitochondria. I don't think the phenomenon has been studied well enough.
Okay.
Like, I don't think we know why these stem cells are not as effective, but it comes from studies. For example, you take a 4-month-old mouse. So you take a mouse that will live, let's say, 16 months, roughly, okay? So you take now a 6-month-old mouse, and you trigger an injury, and you inject in that mouse stem cells extracted from a 2-day-old mouse, and in another group, stem cells coming from a 14-month-old mouse, geriatric mouse.
Okay.
And then you can see that the potential the boost in repair is much better with the young stem cells.
Okay.
So we can tell that stem cells that are younger work better in
Okay.
terms of repair. But they're still working even when they're old.
Yes. Okay. I get what you're saying now. That makes sense. So